I'm Katrina Allen, Head of Alumni Relations and Regular Giving here at the University, and I'm really pleased to welcome you all to our special event for engineering graduates. Before I hand over to our academic colleagues from the school, I first need to cover just a few housekeeping items for people who are unfamiliar with using this platform. Firstly, you may have noticed pop-up notifications on your screen when people join or leave, etc. And unfortunately, we can't turn that off for everyone, but you can turn it off yourself. And my colleague Gary has put up a slide with some instructions on how to do that. If you haven't done so yet, if you click on the purple icon at the bottom right-hand corner of the screen, this will open the Collaborate panel. Then just follow the steps on the screen to change your notifications. As you'll have noticed, the option to use the camera and microphones has been switched off for our attendees, but you can still use the chat box at the side to ask any questions. The chat function is also found in the Collaborate panel by clicking on the purple icon. We very much encourage your questions, and you can submit them at any time you like. Just type them into the chat box and Gary will read them out during the Q&A portion at the end. We only ask that you keep your questions clear and concise. The hand up icon that you will see at the bottom of your screen will raise your hand. If you need any assistance from us, please click this button and we'll reach out to you by private chat message. And finally, just to note that this session will be recorded and shared online. Okay, that is quite enough from me. So without further ado, I am delighted to hand over to Head of the School of Engineering, Professor Ekaterina Pavlovskaia.
Okay, good afternoon, everyone. Very well welcome to this alumni session. And tonight I'm going to share with you some of my vision and idea for the School of Engineering, and we'll try to put it within the context of the University of Aberdeen 2040 strategy. Thank you very much for finding time to attend this event. And as we have limited amount of time, I will go through the slides quite quickly, but I will be happy to answer any questions you might have later on. So, I believe that you probably follow what is happening with our school over the years since your graduation, and my personal view is that the latest period in the school under the leadership of the previous head of school, Professor Igor Gus, was very successful. The school is in an excellent position now. In the last RF period, we recruited 37 colleagues and strengthened our research performance. We continued to introduce new postgraduate programs and refresh and update our undergraduate curriculum. And so the school is in a very good shape. And today I would like to share with you my view of the school ambitions going forward. I've been in the school management role for a long time, and all of this was discussed extensively with the people in the school. So to share view in some sense. So you can see on the slide a few bullet points, and the first one is to be recognized as an international leader in engineering, education, research and application of knowledge to benefit of society locally and globally. This has been with us for some time, and we made a good progress in building our reputation. But of course, there is always more work to be done, especially as our outside competitors don't stand still. We achieved top 10 ranking in 2 of our disciplines recently, and it was both in the ranking published for 2021, but also for rankings published recently for 2022. The disciplines which appear in this top 10, they vary depending on the ranking, but I believe that we're capable of getting to top 10 in all our disciplines, and also to improve our overall performance in the international league table. We managed to make an excellent progress in building our research funding portfolio, and establishing of National Decommissioning Center recently has been a huge success for the school. But again, I believe that with the new disciplines introduced recently, such as robotics and bioengineering, we are capable to continue to expand and grow our research, and both in fundamental but also applied areas. We already have a number of international partnership and spin-off companies, and to be successful and continue to be successful in the future, we need to grow and expand. And finally, I believe that it's important that we continue to review and update our curriculum and work with industry to equip our graduates with skill to be successful in their chosen career. So I will say a few words now about Aberdeen 2040 strategy and how our school is going to work on implementation of this strategy. So the strategy was introduced last year. It is arranged in 4 themes, and each of the themes have a number of commitment. So here on the slide, you can see on the left, small text in blue, which outlines the commitments for this particular theme. I don't expect you to read this. It's the smallest font is small, and this is the published strategy. You can find it on the university website, and of course, for the university community, it's widely known. So we're already a very diverse school with the staff and students coming from all over the world. However, we still need to work on the equality and diversity agenda and make sure that whatever we do is inclusive and give equal opportunity to everyone. We will work on our next as soon as one application for renewal in 2023, and attractive and retaining women in engineering remain a challenge for us. So we will continue to support our student-led society, and we have excellent societies such as Arabagos or RUVIs who are committed to address this challenge. We're also, as a school, planning to have female-only postdoctoral scholarships, which will hopefully help us to address this leaking pipeline program when and allow female colleagues to progress in the engineering career. We will need to become anti-racist school and go through a careful listening exercise to identify any issues which need to be addressed in our school and wider in the community. For widening access, we will continue to provide fair and flexible entry route to our program. And one of the things which we are doing, we're running a transitional summer school, which proved to be successful in the past, and we will expand on this success, but also will enhance our outreach activities in local schools and colleges. Finally, talking about this theme, it is very important that our staff have a balanced workload, so they have time to do both teaching and research. So the next theme which I would like to talk about is interdisciplinary theme. And a school is already working on all interdisciplinary challenges identified in 2040 strategy, and is actively involved in the development of interdisciplinary centers. Within the school, we will be working to consolidate recently introduced interdisciplinary areas such as energy transition, biomedical engineering, robotics, and transport study. We will continue to support and develop interdisciplinary degree program and teaching. And here I would like to mention programs like oil and gas and petroleum engineering, which we run together with School of Geosciences, biomedical engineering, which we collaborate with medical school, industrial robotics, which we collaborate with School of National Computing Science, and programs like the commissioning and energy transition system and technology, where most university schools are involved. So finally, here, the last bullet point on this slide is on our industrial advisory board, and we will look into composition of industrial advisory board and try to expand it to cover all different areas which we now have in the school. So theme number 4 is international school, and we are very, very active in this area already. We have a successful 3+1 program, which is BEng in civil engineering with Harbin University of Technology. The students, we have students studying with us who are now in their second year, so we're running it for 2 years already. And the idea is that the students are in Harbin for first 3 years, and we contribute to teaching either online. It was online because of the pandemic, but ideally we would like to go to Harbin and teach the students there in person. But then finally it's a 3+1 program, so we will have in 1 year time, when they are entering their 4th year, we will have students coming to study with us here in Aberdeen. Similar program, but 2+2. We have articulation agreement with Shanghai. We have also articulation agreement with India and Malaysia, different institutions. So we are developing those collaborations. We are actively participating in the stage 2 of the Qatari project. I'm sure most of you know that Aberdeen University have now Qatar campus, and it was operating for some time. It is the first stage was successful, and now the second stage is actively being discussed and developed, and the engineering will be involved with some undergraduate program or potentially some postgraduate program. So going forward, we will also look at the development of research project and joint PhD degree with the institution where we already have teaching collaboration, and then we'll be expanding our research collaboration with international partners through externally funded project and joint PhDs. Final theme I want to talk about today is sustainable theme. And talking about sustainability, first of all, we will need to ensure that our school operation remains viable and sustainable. Going forward, we will work on the development of the newly established research area in energy transition, transport study, and hydrogen technology to contribute to this net zero agenda. We will strengthen research on net zero related subjects as bioenergy, wind energy, energy storage, and also on carbon capture utilization and storage. So we also lead cross-school Liverpool Center for Doctoral Training in Sustainable Production of Chemical and Materials. So we are, this is just a few things to mention which we are doing in each of the things. You know, of course, the activities of the school are much wider and bigger, but, you know, I thought that it would be nice to give you some examples of what we're doing and where we're going. Finally, we see a lot of challenges facing us, and both internal and external challenges. Here, recruitment of high-quality postgraduate research students is probably something which I want to mention. Obviously, Brexit and pandemic had a huge effect. Now, a lot of our activities will be driven by climate change challenge, and aim to achieve net zero in Scotland by 2045. So the students' recruitment is significantly affected by all of this. Other thing which, you know, I want to mention here is studying flexibility. We were teaching our students online for good part of 18 months, and I see this an opportunity to perhaps look into our overall curriculum and see if we can offer some part-time, mostly online undergraduate degrees to our potential students going forward, building on our experience of teaching online. In research, again, number of challenges you can see on the screen. For us as a school, we've grown and expanded a lot in recent years. We have around 100 of academic staff. This includes our professors, readers, lecturers, senior lecturers, but also our postdocs. So for us, laboratory space for experimental research and space for spin-off company technology development remains a huge challenge, and we will be looking with the university to address it. Okay, I think I spoke for long enough. Thank you very much for your attention. And if you have any questions, please do post them in the chat. I will pass back to Gary.
Thank you, Ekaterina. If we can pass over to Sumeet now, thanks.
Yeah, thanks, Gary. Thanks, Ekaterina. Thank you all for attending this event. I'm going to take this opportunity to share the work that is happening in the robotics, artificial intelligence space within the School of Engineering. Bear with me for a minute. Okay. Could somebody tell me that you can see the slide that I'm posting here?
Yes, we can see that. Thank you.
Yeah, fantastic. Thanks, Gary. So the entire artificial intelligence, robotics, mechatronics sort of work that's happening at the School of Engineering is currently getting collected together in this group, Artificial Intelligence, Robotics and Mechatronics Systems Group, or ARMS. I lead the group currently with Andrew Starkey, Alina Giannacini, and Pascal Meissner as constituent members. And we basically do all aspects of artificial intelligence, robotics, or mechatronics. So I'll have videos in later on to sort of showcase the toys that we get to play with. So we do design, sensing, and instrumentation of systems and robots for automation. We've done sort of the geeky modeling, dynamics, control, and then finally ended up with optimizing certain design parameters or control parameters and so on. And how did we get here? So that's, again, tying back to this story of Aberdeen 2040. When the new principal was inaugurated, the university floated 50 new academic posts. I bid for 2 posts to sort of collect this, robotics AI work together. I won that bid, so we could get 2 academic positions, 2 lecturer level positions at the School of Engineering. And the main aim was to develop not only the research side of things, but also the teaching programs portfolio that we had. So we recently launched an MSc in industrial robotics starting September 2021. We have now gone through an approval process for an MEng electrical electronics engineering with robotics that will be offered from next semester onwards. We have developed CPD courses, and the National Manufacturing Institute at Glasgow helped us in sort of publicizing one of that. We delivered one of these courses to industry partners in 2020. And then the pandemic hit, and we are sort of in limbo, but hopefully that will pick up as soon as the impact of the pandemic sort of goes down. And finally, because we now had 4 staff members who had this synergetic research portfolio, we got together to form ARMS, which is the group that we have just established. Here are the resources that we have at our disposal, the projects and the outputs. This is just within a year. So the group was established in about March of this year. We have a qualified lab technician, which is sort of key to everything that we do in the experimental side of things. We have a really well-equipped lab thanks to the Development Trust, as well as the School of Engineering and various other funding bodies who gave us a significant amount of money. Also some alumni who sort of donated a few pieces of kit.
Sumeet,
This group now, yeah.
sorry to interrupt your talk. We're still seeing the first slide on your.
I don't know why, because.
And it's not showing up on the full screen. It's just the. There we go. That's it now.
Now you can see it?
Yep, it's not in the full screen, but we can't see the slide.
Okay, so I'll just use it this way then, because I don't know what's happening. Make it bigger, maybe. Yeah. So we now have projects ranging from human-robot interaction to AI techniques for data interpretation in oil and gas industries, in vibration isolation industries, and so on. We have collaborative projects to design nano-positioning systems for like atomic force microscopes, which then enable technologies like stem cell research, new vaccines, study of virons, etc. We recently finished a small project on smart masks for minimizing pathogen exposure, and it has now gone through the preliminary approval from the NHS. We'll be looking at sort of a bigger scale project and clinical trials. We have undergraduate projects which were funded by Carnegie Trust on artificial neural network-based control of robotic actuators, as well as self-balancing robots. And in a small space of time, so perhaps in the past 1 year, we have managed to deliver on quite a few things. So we've received funding, competitive funding bids to the tune of $250,000. Quite a few journal and conference papers. We won 4 visiting fellowships, and we have also won 6 funded PhD studentships. So that sort of enables the research that we're doing. And what is it that we're doing? So here it is. These are projects that are currently in progress, and toys that we get to play with. So that's really exciting for us. Here's a mobile platform that we've just recently purchased, and the idea is that it has a payload capacity of about 10 kilograms. We should be able to put various sensor arrays, maybe even a pick-and-place robot arm, and allow this platform to be programmed to sort of, navigate through obstacles and courses and deliver some tasks. Another project that we're working on is fusing machine vision to look at multi-object handling. I mean, humans tend to take a lot of things as simple or granted because it's inherent to our capacity, but when we want to translate that into a machine, it really is quite difficult. So here's a task where you have a box with a lot of objects of various shapes, sizes, and colors, and you're commanding the robot to pick and place a specific object from one box to the other. And you see the decisions that the robot has to make based on a camera that is attached there. So that's a small cube that it picked and placed. The next one is supposed to be a plier, and the robot has to sort of reorient itself, need to make sure that the jaws open and closed at the right angles and the right widths to be able to sort of pick that plier up. And then there is also this idea of resolving color and contrast within the box to find the right object. The third project that we're working on are very cheap 3D printed pneumatic soft actuators. So this is sort of the bio-inspired robotics that we are looking at. So this looks very much like the arm of an octopus, and you apply pressure to it, and the air chambers there sort of expand or contrast, and then you can move or change the shape or deform the shape of this actuator. You can then connect them in like a finger, a hand grasp mechanism. What we would aim for is to miniaturize them so that they start mimicking behavior of cilia in protozoa and start moving aquatically. We do a decent amount of theoretical work as well. So here is a artificial neural network AI-based project that we did. Here is a sort of maze, and the mouse needs to get to a burger. And the Q-learning algorithm is something that is quite popular. You do a few runs, and the mouse starts to find where the burger is. But as soon as the sort of path changes, so the environment changes, the mouse is lost. And you see how much time it's taking to sort of figure out that there should be some other way to get to that burger. And we tried this, explainable AI. So it understands what we need to look at in terms of the environment. And if you see what the outcome is, then the mouse is sort of going to learn what the environment is in a couple of runs. And as soon as the environment changes, so there is a wall there, the mouse sort of waits, thinks about what the environment change is, and starts planning an alternative path. It sort of reaches the burger quite quickly. Whereas, if you look at the time that is elapsed here, I mean, it's still sort of, it's still nowhere near the end result. So these sort of the theoretical algorithmic improvements that we can do using explainable AI in reaching targets, path planning of robots. And then there is some control. So here is a flexible robot mock-up. Flexibility is sort of enforced when we start making lightweight structures. And we want to make lightweight structures because heavier the structure, the more energy required to move that structure. So if we sort of look at this robot to begin with, I really don't know what is going on with my screen here. There, yeah. And I'm just asking the robot to move a certain degree, and because of the dynamics, you see that instead of sort of stopping at a particular stop point, it sort of shakes up. We now design a controller, and then it goes to where it wants to go. But robots are usually used to pick and place things. So if you add a weight at the end of that structure, which is there, the dynamics of the robot change, but you can't really go on tuning the controller in real time. You just want one controller set engaged with the robot and should still do the same task, and it does it here. Flexible structures, so these kind of robots are sort of used in solar array booms in satellites where you can't really go up and start tuning controllers and so on. So here are some of the recent videos. The future projects that we are interested in, we have some kit. We want some support in terms of resource, human resource, PhD students, as well as financial resource. So arthropod-like robots, in a sense, crab-like robots for hazardous environments. Wheeled robots have their pros, but they also have their cons when it comes to sort of uneven environments or trajectories, terrains, whereas crabs tend to do quite a lot of good things with multiple legs. There is redundancy for a loss of leg and so on. Pneumatically actuated soft robots for dexterous manipulation. So we want to sort of mimic the human hand. The human finger really has 3 joints, or in a sense, 3 degrees of freedom where it can bend. We want to know whether that's the most optimum or whether we want to go higher than that or lower than that. Dielectric elastomer actuators are basically rubbers which change shape when you excite them electrically. And we can use them to sort of position certain things very precisely. They're currently in vogue for invasive surgery or minimally invasive surgery, active catheters and so on. And we have a collaboration with Shanghai Jiotong to work on that. Machine learning for intelligent multi-object handling, it's something to do with the Industry 4.0, where packaging is skills. Then you have various sizes of packages that need to be sort of aligned, shipped, packaged, and robots would ideally be doing those things. Explainable AI for the industry. So AI usually used to be this box that nobody knew what is happening inside, and you only got some input from somewhere, which was data, and then it gave you an output. The limitation of that is because we didn't know in detail what changes inside this box that allows the box to work, the processes around it couldn't be optimized or improved. But now we can actually look into this box, and that's the explainable part that allows us to improve processes where this AI can make a bigger impact. And then we're also interested in the self-aware reconfigurable swarms of robots. It's sort of mimicking the hive of a honeybee, where every honeybee knows what its capability is and what its duty is. But if there is a job which is beyond the capability of a single honeybee, then it can communicate to get more help from other honeybees. So that's the swarm behavior that we want to mimic. But that's sort of the gist of everything that we are trying to achieve within this exciting arms space. As always, thanks for the attention, and if you have questions, comments, I'll be very happy to hear from. And that is all from me. So probably Ed is in line next.
Yes, thank you very much, Sumeet. Afternoon, everybody. Thank you for coming to listen to us this afternoon. So my name's Ed Chadwick, and I'm going to talk about bioengineering and biomedical engineering in the school and the developments over the last couple of years. You will notice that there's a little bit of overlap with some of the work that Sumeet talked about as well. So I'm going to very briefly define our terms a little bit, because there is some variability in people's understanding of what is biomedical or bioengineering. I'll very briefly talk about the department, the school, university context for the creation of this research and teaching area. And then I'll give some examples of some of the research projects that we're currently involved in, and talk about the new educational provision that we've started in the last couple of years and where we hope to go with that as well. So if we think about what we understand by biomedical engineering, then in the broadest possible sense, we're talking about the application of engineering principles to the solution of problems in medicine and biology. And personally, I use the term bioengineering really to talk about the field in the broadest sense, such as defined there. And biomedical engineering is where we're specifically focused on solutions to healthcare problems and medical problems related to medical devices and so on. But you'll see there is some variability in that. But one of the important things that I want to emphasize here is that it is very much an interdisciplinary field. So communication is extremely important between stakeholders from different backgrounds and people working in different areas. So the ability to work across boundaries and communicate across boundaries is very important, not only from completely different disciplines, healthcare, medicine, biology, engineering, but also across different disciplines of engineering as well. So you'll see that quite a lot of the examples that I talk about are really very much at the interface of, for example, mechanical and electrical engineering. And it is a growing field as well. If we look at these statistics here I have from the US Bureau for Labor Statistics, they forecast 6 to 7% growth to 2030. And really, I see no reason why it would saturate at that point either. It's still a relatively small field and will continue to grow for quite a long time. So it's an important area for the school to be developing new research and teaching provision in, I think. And so the employment opportunities for graduates as well as research in this, right across the development, operation and regulation is likely to be quite a strong growth area in the future, I think. I just wanted to briefly share this definition about bioengineers from the American Institute for Medical and Biological Engineering. And they say bioengineers work with cutting-edge technologies to tackle grand challenges that define the human experience. They advance human health, engineer better medicines, create the tools of innovation and scientific discovery, and harness the power of biological processes to aid our planet. Now that was obviously extremely broad and extremely ambitious and sounds very exciting. But it does give some idea about the breadth of research that can come underneath this heading. So we are focused at the moment at least more at the biomedical engineering side rather than the bio or the biological engineering side, I would say. And the picture on the right there shows a prosthetic limb, a prosthetic toe. So this is an artificial toe to replace somebody who's suffered the loss of a part of the digit through an accident or something like that. And this is actually 3,000 years old. So this is an artificial device that has been engineered to replace a missing part of the body, and it goes back a very, very long time. So it's not a new field, although in some ways it's new to our school. It is well recognized by the professional engineering institutes. So if we look at some of the well-established ones that we know, so the IMechE, the IET, and the IEEE, we're probably very familiar with. The Institute for Physics and Engineering in Medicine is probably the main professional engineering institute for practitioners in this field in the UK. But all of these PEIs recognize biomedical engineering as a standalone discipline within engineering. And it has existed probably for about half a century. Scotland, in fact, has been quite active in this field for a long time. One of the first MSCs in the UK in biomedical engineering was at Strathclyde, and there's a history of this topic, at least within at Aberdeen, going back quite a long time as well. So I just want to talk briefly about the university context. I came to Aberdeen about 2 years ago, just over 2 years ago now. And as I'm sure you're all extremely familiar, the School of Engineering here has a very strong foundation in general engineering. And that's a really good basis for the introduction of interdisciplinary programs, both in research and teaching, such as biomedical engineering. There's also, of course, a very strong medical school, and established research areas in disciplines that bring those two together, really. So medical imaging, regenerative medicine, biomaterials, artificial intelligence, as you've just heard about from Sumeet as well. There was also a very well-established MSc program in biomedical physics that's been going for a very long time, decades. And that's, for the Institutes of Physics and Engineering in Medicine, that is considered to be a sibling course for biomedical engineering. So there's the two branches of clinical engineering and sciences working in hospitals. So medical physics or clinical engineering really go together. There's also a wide range of existing courses within our school from which we could draw on to establish new programs, and I'll say a bit more about that in a second. And of course, just to re-emphasize the 2040 themes that both Ekaterina and Sumeet have mentioned as well, bioengineering, biomedical engineering, as I've said, is by definition a highly interdisciplinary subject. It's inclusive in the sense that we're trying to recruit students from non-traditional backgrounds to come and study biomedical engineering within our school, so not necessarily people who have already studied some other form of engineering or just physical sciences prior to coming here. And there's a lot of scope for development of biomedical engineering internationally as well, with advances in medical technology. So I think it's an important topic from all of those perspectives as well. I'd just like to mention a few of the research areas. I'm not talking about one particular group here. I'm talking very broadly about research areas under the heading of biomedical engineering that are happening right now in the school. The first one I'm going to mention is the one that I'm most closely involved with, and this is healthcare technologies. The headings I've used for these next 3 slides, by the way, come from the priority areas from the Scottish Research Partnership in Engineering. So that's why I've chosen those headings. So healthcare technologies is one of them, and in particular, we're looking at developing novel assistive devices and technologies for people with disability arising from physical injury, such as spinal cord injury or limb loss, or nerve injuries, orthopedic injuries, things like that. So we have one project which is looking at developing better controllers for electrical stimulation of the muscles to restore movement in people with spinal cord injury. We're also looking at better control of prosthetic limbs for people with arm and hand amputation. So myoelectric devices, so powered prosthetic devices for the hand, looking at trying to improve the control of those devices. And we also have some more fundamental work in biomechanical modeling to improve orthopedic interventions. And that's the picture on the right shows a graphical representation of a computational model that is used to understand the biomechanics of the limbs. A rather newer area that we just started working on, and again this one overlaps with what Sumeet was talking about for the robotics, is the use of the soft robotic actuators as assistive devices for people following stroke for rehabilitation of the upper limb. So that's just a few examples of some of the things that we're working on. In other areas of engineering, particularly in fluid mechanics, we've got some research in modeling soft tissue mechanics and modeling drug delivery optimization for brain cancer therapeutics. So that's really sort of at the interface of mechanical and fluid mechanics with some input from chemical engineering as well. That's an ongoing project that's got a PhD student working on it at the moment. That's led by Wenbo Zhan. The artificial intelligence, again, Sumeet already mentioned, really, but explainable AI applied to medical imaging is an area that we're quite interested in. And also in the area of fluid mechanics, computer simulations of mass and heat transfer in droplet-laden airflows with obvious topical applications in looking at the pandemic response. We hope not to have to be researching in that area forever, but it's, as we're all aware, it's still ongoing at the moment. And the final one I want to talk about is improving patient and clinician experience. And this is more broadly about different types of engineering modeling applied to healthcare systems. So we've done a little bit of work modeling for pandemic response planning, so looking at how to optimize the resources needed to deal with under changing conditions of infections, for example. We're also interested in wearable technologies for continuous and remote diagnostics and monitoring. Again, that's the remote aspect of that is quite relevant at the moment, but actually I think will be highly relevant going forward for the delivery of healthcare, particularly in what is a relatively rural catchment of NHS Grampian, well beyond the pandemic. And actually, I'd just like to highlight that in all of these areas, we have PhD students who are active and some research assistants as well, school and externally funded PhD students. And we've developed a number of new collaborations as well as strengthening existing national and international collaborations in these areas. Now, the last thing I want to mention is about the educational provision in the area of biomedical engineering. So I've mentioned IPEM at the start, the Institute for Physics and Engineering in Medicine. And one of the things that they want to do is to increase the academic diversity of applicants coming into biomedical engineering programs in order to broaden the possible destinations that they can go into as careers. It used to be that IPEM was primarily concerned with training clinical engineers just to work in the NHS. Following a restructuring of that training scheme about 10 years ago, they broadened their remit and wanted to expand the programs that they oversee so that the graduates of those programs are equipped to go into biomedical engineering workplace in a range of destinations, whether that be in industry, working in medical device research and development, in healthcare settings, working as clinical engineers, or in academic environments, carrying out fundamental research in the area of biomedical engineering. So the first thing that we've done in the last year or so is to start a new MSc in biomedical engineering along those lines. I'm not going to spend very long on this, but I just wanted to highlight here the structure of this MSc is interdisciplinary in the sense that it's delivered not just by us in engineering, but also by people in medicine as well. So all the green blocks in this diagram over here are from medicine. So we can take in students from an engineering background, and then they're taught biomedical and professional topics in healthcare sciences, which is essentially anatomy and physiology for engineers. Or we can take in students with a life science or medical background, and they do the introduction to engineering for life scientists, and that allows them to then go through the rest of the program, studying the more advanced modules, such as the modeling for biological systems or rehabilitation engineering and biomechanics. And students also have the option of choosing courses from well-established engineering courses, such as composite materials, finite element methods, or they can choose things from a School of Medicine, such as the commercialization and biobusiness options. So it's a nice customizable and broad program. And actually the first cohorts from this MSc will graduate next week, so that's very nice. That's the first one that we started. The potential for new programs is quite strong in this area as well. So our existing MSc has a relatively strong mechanical engineering slant to it, and that reflects the strengths of the people involved in that primarily. But with minor changes in some of the core courses, we could have a biomedical engineering course that has more of an electronics or a chemical engineering slant to it, as well as more specialized options. I think there's the potential for online delivery of some of these programs as well. We have to think carefully about the student experience in terms of practical and clinical experience that the students would get. But I think there is definitely room for exploration there. And in terms of undergraduate programs, we're looking at the possibility of starting undergraduate programs in biomedical or perhaps mechanical and medical engineering, something like that. In fact, we have a new variant of the mechanical engineering undergraduate, which is mechanical engineering with biomechanics, already approved and on the books. We haven't quite started actively recruiting for that one yet, but it is there and ready to go. So in summary, I've just given some examples of new research areas in bioengineering that have contributed to the growth in this area, adding on to existing research which was already here related to bio and biomedical engineering. I've given a very quick overview of the new educational provision that we've established in the last couple of years and where we hope to go with that. And finally, I've mentioned new collaborations and development of existing collaborations. And finally, I want to say also that we're very grateful to the school and the Development Trust for the support that they've provided to us for developing these areas. Okay, thank you very much for your attention. I'll hand back to Gary now, I think.
Great, thank you very much, Ed, and thanks to Sumeet and Ekaterina as well for your presentations. Great to see all the fantastic work that the school's doing to help our students here at the university. My name's Gary, and I work in the Alumni Relations team, and one of my responsibilities is to liaise with the School of Engineering. So I'll be moderating the Q&A session that we're about to undertake. So we've got quite a few questions in already, and the first is from David, who asks, does the school have any work with renewable electricity generation?
Thank you very much for your question, David. So yes, absolutely. We are working on renewable energy generation. We're working on wind turbines. There are some very interesting projects happening in the school, which is kind of novel technology development from utilizing rotating pendulum and on the sea waves. Had a number of PhD completed in these areas. So I just want to kind of emphasize, because I've seen these questions on the chart, and when we were planning this alumni event, the idea was that we basically bring some new and exciting area in the school rather than going through everything which we do. And we ran very recently, I think maybe less than a year ago, we ran an event when we were showcasing what is going on currently in the school, and we had kind of very detailed presentation covering all sorts of areas. So today we thought that it would be nice to do something different, and we only presented really 2 new areas which were recently established, and so the focus of this meeting was on the new areas and us going forward. And you know, we are still doing all the classical research and working across 5 disciplines: mechanical, civil, electrical and electronics, chemical and petroleum engineering. We have very extensive research in all of those areas, but today we were showcasing the newest addition to the school, because we thought that it's new and might be interesting to our alumni to learn about, because those areas might not be in the university when you were doing your degree.
Yeah, I think that's right. There's so much that the school does, but we can't fit everything into an hour, so it's kind of a couple of highlights from it. Related to that question, Ekaterina, Martin has asked, will the university be involved in the setup of the wind energy hub in Aberdeen? The hub was mentioned by BP's head of North Sea on a University of Aberdeen presentation recently.
We are involved in many different initiatives, and you know, you might know that the university recently appointed our newest VP on regional engagement and regional recovery, Professor Pete Edwards, and I'm sure that Pete is involved in talking and all the relevant stakeholders and making sure that we are contributing. From the engineering perspective, I'm not aware that we are taking active part at the moment, but it doesn't mean that it's not happening. It just might be me not being briefed, as you mentioned, it's quite recent.
Great, thank you. Katrina's asked, she's wondering if the school is seeing an increase in inquiries from prospective students interested in degrees related to the net zero agenda.
Thank you very much for your question, Katrina. It's a really good question. So one of the things which I mentioned in my presentation, and I kind of mentioned it in passing rather than spend a lot of time on it, but I think actually last year we introduced, and this year we took first intake of our newest recruits and newest students for the new program, which is Energy Transition System and Technology. So this is very much related to this net zero agenda, and I have to admit that we are seeing quite a bit of interest in this program. For the newly established, newly introduced program, we have very healthy intake, and we expect that this program will grow, and some of our students on our classical mechanical or classical civil degree will have access to those newly developed courses in energy transition, and they will benefit from this.
Thank you. William's asked a question, which I think some of it you've already possibly answered. It seems that the research interests are narrowly specialised, while the three collaborating countries are developing rather than advanced countries. I would have expected collaboration with the countries traditionally associated with large Scots diaspora, like Canada. Also, there seems little interest in traditional engineering infrastructure. He also goes on to ask, what is your percentage of female faculty, staff, undergraduate and graduate postgraduate students?
Okay, thank you very much, William. We do have collaboration with Canada, but as I said, kind of maybe not in robotics and bioengineering, and in kind of our wider activities. For example, I know that Professor Dragan Jovcic has a collaboration with Canadian institution, and he's going for research kind of visit very recently, because I was kind of involved in approval of travel arrangement in the new pandemic or post-pandemic world. So we do have collaboration with Canada, for example, and as I said, we only mentioned very small amount of what we do, small details on what we do. In terms of percentage of the female faculty, staff, and students, so we're typical engineering school. In terms of the students population, I don't have precise numbers on top of my head. It caught me a little bit unaware. But what I remember, it varies significantly between, let's say, petroleum and mechanical and chemical engineering. Our highest percentage of undergraduate students, female students, would be on chemical engineering program, is maybe around 15 to 20%. Then would probably in our particular school, then the next highest would be civil, and then mechanical and petroleum will be the last. So in terms of staff, we're actually doing really well with the senior members of staff. So 25% of our professors are female. We have first female head of school in engineering in the University of Aberdeen in our 525 history. So that's kind of an achievement for the school. There's not too many females head of school in engineering in Scotland or in UK for that matter. we are trying to recruit as many female colleagues as we can. Sometimes it's very difficult, so it's very difficult to recruit. We recently advertised for the position of chair in energy transition. I think we did not have a single female application, so that's that's a reality we are living in. But we do try to recruit for junior posts, and we try to develop our staff and allow them to progress through their careers. All the initiatives which our students undertake to promote the engineering profession to local schools and to secondary school students and perhaps even primary school students. So we see it's very important. We're very supportive of all these initiatives and trying to encourage those.
Wonderful, thanks, Ekaterina. You'll get a bit of a break now because Phil's pointed his question to Ed, and he's asking, we have technology that can give early warning of hydrate onset within a pipeline. Given that veins are a sort of pipeline, would there be interest in being able to predict a blood clot, or is that being done already?
Yes, thanks for the question. I think there certainly would be interested in that. I'm not aware of any work currently going on in that area, but it's not my area. One of the colleagues that I mentioned previously, Wenbo Zhan, whose interest is in soft tissue fluid mechanics and modeling, I think has already looked to some extent at modeling deep vein thrombosis. So he might well be interested in taking this a bit further. I think it would align quite well with that area. So I think there certainly would be interest in that. I think it's blood vessels are pipes essentially, slightly squidgy pipes, but they're all just pipes. And I think there's a lot of things that we can take from traditional engineering disciplines to inform our research in biomedical. I like to think of the human system is a collection of, it's electrical, it's plumbing, it's structural. So I think that fits very well. If I can just also come back to the previous point, I think the inclusion of biomedical engineering is likely to increase our percentage of women students overall. Most institutions that offer biomedical engineering would have a higher proportion of female students in that discipline than in more traditional engineering disciplines. And so far in our MSc in biomedical engineering, half the students have been women.
Great, thanks, Ed. And the final question that's in the chat so far, but if anybody has any questions that they really want to put, now is the time to do it just before we wrap up. Roy's asking, he said for a start, interest in presentations. He's interested to understand a bit more about where the push-pull for interdiscipline education is strongest and what other things may be coming even further in the future.
Okay, thank you very much, Roy. I think it's a very challenging question. In terms of push-pull for interdisciplinary education, we, being a school of general engineering, we are already trying to bring in the interdisciplinarity in the core of everything we are doing, because our students join the general engineering degree, and for the first 2 years they study together. So within engineering discipline, we already have this interdisciplinarity built in, because mechanical engineering take courses in electrical system and vice versa, and they're exposed to not necessarily all, but most of the engineering disciplines which we teach in the school. As we go to the higher years and we specialize more, then there is this more push for interdisciplinarity, but then bringing input from geosciences or from medical school or from business. So it is very much coming to our direction. The push-pull here is, in my view, is an accreditation requirement, and in order to get this accredited engineering degree, we have to satisfy engineering institution, and they're quite rigid in a sense what we have to do. But as Ed pointed out in his presentation, if we're going forward with the biomedical engineering or bioengineering, then the requirement and accreditation comes from sort of different bodies, and the requirement is different. So it's always a balance to strike which way we want to go. What other things may be coming even further in the future? I think the biggest drive, which will be in the next 20 years, is on net zero agenda and energy transition. This is absolutely huge for Aberdeen. So, and if we're successful, if we are to be successful as a university, and if we are to be successful in the city, we will have to move away from oil and gas and to green and renewable energy generation, and all the different initiatives, including not funded at the moment, carbon capture and storage, facility in the northeast, which is very regrettable, but I hope it will come on stream at one point. So this will be our focus, and the school will certainly be contributing to this agenda. So I'm very cautious of time. I hope I answer at least some of your questions. So I will pass back to Kari.
Thanks, Ekaterina. Thanks for all the questions, folks. As you say, we have come to the end of the session, but I'll hand back to Katrina just to wrap things up for us.
Thank you, Gary, and many thanks, Ekaterina, Sumeet and Ed, for your really interesting updates, and a huge thank you to all of our alumni attendees for joining us today and for your great questions. Just to say, if any burning questions have occurred to you after the opportunity to ask them, please just drop us an email. We're at alumni@abdn.ac.uk, and we'll be delighted to help. Okay, thank you, take care everyone, and thanks again for joining us.